So hi there everybody, my name's Sam Hopton, I'm Head of Technical over at Firth Steels. I've been with the business for over 10 years now. My main focus has been on industrial logistics buildings, sort of warehousing, specialist manufacturing. I think one of the key sort of benefits of my role within the business is I sit front face with architects, designers, consultants, but also with the steel mills. So working in the R&D teams, working on product innovation, so it sort of goes full cycle from end use through to product innovation. For the next 30 minutes or so, looking to introduce those of you that are not aware of Firth Steels, who we are, what we do, an introduction to our product range and how our collaboration with both One Click and with SSAB has been sort of critical on our carbon reduction journey. So with me is Gary Matthews, let him introduce himself.
Hi there, like Sam says, Gary Matthews, and I'm the UK sales manager for SSAB Swedish Steel. I've been in the company 20 years now, started off in business development and the usual sales roles, making phone calls, do you want to buy this, do you want to buy that? So 20 years ago, somebody would tell me I was stood on stage talking to a group of people about sustainability in steel manufacturing. I'd have thought you got a bit mad, but this is where we are now, and it's definitely the way forward. So I look forward to talking more about our products shortly.
Cool, thank you. So as Firth Steels, we are an independently owned manufacturer based out of Brighouse, West Yorkshire. Yeah, the slide has gone. So we were founded in 1983. It's family owned, family run. It's been on to the third generation now. So as a steel roll former, we take finished steel coils, on average weigh around 8 tons, and then roll form them into roofing and cladding systems, structural floor deck or structural roof deck. So in terms of output, typically we do 2,000 to 3,000 tons of steel a month. So in metres, that's around 300,000 to 500,000 linear metres of finished products coming out the door each month. So over the last 40 years, we've sort of remained relatively hidden behind our supply chain. I think for structural floor decking wise, we've done the shard, we've done the scalpel, we've done terminal 3, 4 and 5. It's always good to be able to say everyone in the room has stood on our products, but I think today I found out this morning that we did this building back in 2008. So I think it's true that everyone else stood on it today. On the building envelope side, we've done a range of roofing and cladding systems from the NEC. We've done Connect 61, 62 as logistics hubs up in the north. Last year, we supplied 1.3 million square foot of roofing and cladding to a manufacturing facility up in the northeast of England. On the roof decking range, again, we've done schools and universities across the country and into wider Europe. I'd say within the roof decking range, the main growth at the moment seems to be a combination of energy to waste and data centres. They seem to be the two real growth hotspots. Both of those are looking for low carbon solutions within their design. So we're split into 3 main product groups. So we have a building envelope team, we have a structural floor decking and a structural roof decking team. So as a profiler, effectively the coils come in and then we manufacture them through roll forming, and then they roll form into the finished products that then go out of the door. So on the building envelope side, we have our Protect system. So it's a built-up roofing and cladding system, generally focused for the UK market. It can go from anything from individual trade units like a Screwfix or a Costa, all the way up to large-scale distribution centres and logistics hubs. We've got 2 different options. We have our Protect Classic system, which uses standard blast furnace steel, and then our Protect Voyage is a low-carbon alternative, which we're going to go into a little bit more detail later on. So with a built-up system, you typically have a steel liner tray that sits directly onto your purlins or your cladding rail, a spacer system to create the cavity, which is filled with glassable insulation, and then an external profile to give you external surface texture, your profile, your shapes, and your finishes. The structural floor deck range is typically used as a composite floor system, so the decking will go down, the concrete's poured on top, and then that forms part of your composite slab. So typically that's used on your multi-storey high-rise buildings. And then your structural roof decking is then used under sort of standing seam systems or flat roofing, again, where you're looking for low eaves heights in flat roofing systems. I'd say there's multiple benefits to each different type of system, but they are unique. But from our perspective, they are all a roll-formed finished product that's going out of the door. It can vary. Sometimes we can have 10 deliveries going out today. Sometimes we can have 5 deliveries going out today. They're all normally full Arctic loads going out that are full steel going through. So within the Firth group, we also have SMD, Structural Metal Decks, who design and install in partnership with us our structural floor decking. So it was SMD that built the floor decks we stood on today back in 2008. So as a UK manufacturer, we have a global supply chain. We work with steel mills all across the world. I think it's the steel industry is quite fragmented in that you have a lot of different steel mills that have got a lot of different priorities that can either be micro-geopolitically or could be on a broader scale. So it's all about finding the right partners and the right mills that you can work with, both commercially, but then when we look at carbon reporting, responsible sourcing, that can have a major impact on the products that we need to supply. So our range starts off at 0.4 thick, and then we go all the way through to 10 mil for our trench sheeting products. We can have hot rolled, we can have galvanised, we can have painted and specialist steels. So it's a broad range to cover and difficult to find a one-size-fits-all when you look at all the other factors included. So SSAB have been one of our key strategic partners for over a decade. We've worked very closely together, but I think in the last few years it's when it's really looked at the decarbonisation strategy that Firth Steels are on, and that's where the partnership has worked very well. So as a business, we are probably a little bit late to the sustainability game, in honesty. I think it's one where it's the supply and the demand for low carbon steel. I'd say the demand has normally been there. The supply hasn't always quite been there. And I'd say there's been definitely a change in the last couple of years that EAF low carbon steels are now becoming readily available. And I'd say that's been the real demand increaser. So I'd say as a business, I think during COVID, we had sort of a bit more time to take a step back and look at the business holistically. And it was a case of looking at the core values as a sort of family owned and operated business. The decision to accelerate our decarbonisation journey was taken. So we partnered with Planetmark as our decarbonisation partner. So they gave us a baseline review, and then we've also done a year-on-year programme with them to reduce our embodied carbon. So I'd say the scope 1 and 2 emissions have been a relatively positive journey year on year. We're looking at around 30 tonne reduction in our scope 1 and 2 embodied carbon. So we benefit from being a single source, a single manufacturing facility in Brighouse. The roll forming technique, it doesn't use heat, it doesn't use chemicals, it doesn't use water, so a lot of it is just the energy consumption that we're using on site. So we have a 200 kilowatt battery system, 200 kilowatt solar system that feeds into a 500 kilowatt battery system. That has been sort of designed and utilised to try and reduce our energy consumption year on year. So it's sort of split from 2 primary uses. In the summer months when we have a lot of sunlight, we run a 7/4 production shift, so we can reduce during the summer months our energy usage by up to 90% from the grid energy. The battery and the solar then working in tandem to cover both of those areas. In the winter months, we can then use the battery system as a UPS backup to give us that energy security. We are on the side of a river, so it just gives us that backstop in case we need it. Max output, it can power the site directly off the battery for around 6 hours. That varies depending on the sort of sun and input that's coming into it. So year on year, our reduction has been relatively positive. With Planetmark, we then moved on to our full net zero benchmark or baseline where we covered our scope 1, 2 and 3 emissions. And all of a sudden, the 64 tonnes of carbon saving that we'd made over the years was sort of became lost in 49,000 tonnes of embodied carbon within our scope 3 emissions. So of our scope 3, we are looking at around 49,000 tonnes of carbon within our scope 3 emissions. The left-hand chart, we've got 74 tonnes give or take for scope 1, 84 tonnes for scope 2, so you can't even see them on the charts to be fair, and then within the green sections we're looking at 99.7% of our embodied carbon is directly related to our scope 3 emissions. When we break that out onto the right-hand side, that is our goods and products purchased. You can see again the 48,000 tonnes is split into 47,000 for steel, and everything else then falls into 538 tonnes for all of the packaging and everything else that goes into it. The major risk for us at the moment is when we look at decarbonisation, with policies like CBAM coming in, the industry is going to change dramatically over the next 12 months, and it's making sure we're in a good position to be able to facilitate low carbon options within our range. So I think looking at those 2 slides, it's clear that our supply chain partners are crucial on our journey to reducing our embodied carbon. So I shall pass over to Gary.
Thank you. Right, so yeah, like I said earlier, Gary Matthews and SSAB Swedish Steel. SSAB is a steel producing company based up in Scandinavia. We've got places up in Finland, Sweden, and across the pond in the Americas. We produce about 9 million tonnes of steel a year. It's quite niche, the markets we go into, yellow goods, we're world leaders in ultra high strength steel, painted products which are supplying to Firth Steels, but we're also probably the world leaders when it comes to sustainability for the steel sector. So just a bit of a update as to where we are. That helps if you click that. If it works, there we go. So as we can see, the steel sector emits almost, or contributes to about a quarter of the world's CO2 emissions, which, as you can imagine, is quite a lot. If we look at SSAB alone, we are contributing about 10% of Sweden's CO2 emissions and about 7% of Finland's. Let's do that one as well. Hang on, we'll get there in a minute when we get this working. There we go. So you can see on this graph, what we have here is by using original blast furnaces for steel production, we emit approximately 2.5 tonnes of CO2 per tonne of steel produced in its end stage. So that's through the blast furnace, through the steel slab production, the hot roll and the cold roll and painting. We are at the moment, and we always have been, the cleanest steel mill in the world. So if you look at the averages in comparison to other steel mills, we are still well below other steel producers, but we are going beyond that. So you need scrap to produce steel. Steel producers are making steel to last longer, but also with a growing population, there won't be enough scrap in approximately 25 years' time to produce the amount of steel the world needs. So we still need an element of scrap as well as virgin material to keep up with demand as we move forward. So there is a need for change, and how do we do this? So SSAB, we have two routes to decarbonise the steel sector for SSAB. We have SSAB Zero, which is a 100% scrap-based production through electric arc furnace, powered by 100% renewable energy. We'll talk about that more shortly, and we also have fossil-free steel production, which is our unique way of producing steel. So it's hydrogen-based, green hydrogen produced by SSAB, and that'll produce virgin steel as we move forward. So the timeline for all this, back in 2016, someone came up with a great idea, someone a lot more clever than me, to how we can produce steel and reduce our carbon emissions to zero. We signed off and we actually decided to build a demonstration plant. Now, a demonstration plant will produce about 1.3 million tonnes of steel when it's up and running in a few years' time. But if we go down the line, so we actually produced the first tonne of fossil-free steel in 2021, which actually ended up in an autonomous vehicle for Volvo construction. The whole project was brought forward about 15 years back in, I believe it was 2023, from 2045 to 2030. So brought forward 15 years to completely decarbonise SSAB Swedish Steel. 2030 is still a bit off. So we thought, what can we do as of now? As of now, we can produce steel with zero carbon emissions through SSAB Zero, which we'll come on to more shortly. But the fossil-free steel is a program called HYBRIT, which stands for Hydrogen Breakthrough Iron-Making Technology. It's a joint venture between SSAB, a company called LKAB, who are a mineral ore producer, and Vattenfall, who are a green energy company based over in Sweden. So this is the plant, like I said earlier. We call it a demonstration plant, but it's on a bigger scale than what you'd imagine as a demonstration plant. And when this is operational, commercially in 2027-28, like I say, we'll be producing about 1.3 million tonnes of steel through this plant. I do have a short video here just to give you an explanation of how it works, and we'll talk more about it after. See if somebody can.
The process behind HYBRIT. World's first fossil-free steel. Blast furnaces are still used to convert iron ore to iron, just as they have been for the past 1,000 years. This traditional process uses coal and coke, which become carbon dioxide. With HYBRIT, we will use a new, revolutionizing direct reduction process, replacing coking coal and natural gas with hydrogen. This involves the use of two key components: iron ore pellets that have been mined and processed without fossil fuels and CO2 emissions, and fossil-free hydrogen. This process emits water as a byproduct, instead of carbon dioxide. That makes HYBRIT fossil-free steel unique.
Right, so that's the technology. So just I won't go into full detail, but just a brief overview. So we're making green hydrogen using fossil-free energy and water with electrolysis. And just I think quite a fascinating actually piece of info is, as I said, when you produce a steel slab using the original blast furnace process, you produce about 1.6 tonnes of CO2 per 1 tonne of steel. With this process, we're producing 0.05 kilograms per tonne. But the most exciting fact is actually the byproduct, instead of being CO2, is drinking water. Not that you're going to see SSAB drinking water in the bottles of shelves of Tesco anytime soon, but the water produced is then going to be recycled to make the next batch of green hydrogen, and the amount we need will produce the next batch of steel through the process. So it's a circular process. Why is Scandinavia so good at producing fossil-free energy? Because there's an abundance. I think 99% of energy used in Scandinavia is fossil-free. I heard a great fact recently that in Stockholm at certain points of the year, if you plug your car into charge, you actually get paid for charging your car as opposed to paying to charge your car. There's an overproduction of fossil-free energy. So we're perfectly situated to produce the green energy we need to produce the green hydrogen to power our steel mills. Like I said, prior to the HYBRIT being available in 2030, so 2027 is the plan to actually start producing steel using the fossil-free technology. And at that point, we will produce approximately 1.3 million tonnes out of 9 million tonnes what we produce at this moment in time. 2030, we will have decommissioned all of our steel mills and built new mills to produce fossil-free steel. So by 2030, the steel mill, we will be as close to zero carbon emissions as you can actually get. In the meantime, like I said, we have SSAB Zero. Now, as I mentioned earlier, because of the finite amount of scrap available in the world, you can't just replace every tonne of steel we produce as a steel mill by this process. So you are limited what we can do. At the moment, we're producing approximately 150,000 tonnes per year. This is available as of now and has been since 2023. And there's actually a few examples where we've supplied into Firth Steels who have actually made buildings using this material. So again, in comparison to original blast furnace material, 1.6 tonnes of CO2 per tonne of steel. SSAB Zero produces 0.05 kilograms per tonne. So quite a big saving on carbon. So just to recap across the three processes I spoke about, is we said, so you've got your original blast furnace material, the oxygen-based. On the left-hand side, we're using coke and coking coal. That's what produces your CO2. As you can see the figures for producing a slab of steel, this is per tonne, you've got 1.6 tonnes of CO2. The next process is the HYBRIT technology, where the CO2 will be reduced to 0.05. And then the third option is SSAB Zero, which is available commercially now, and that also reduces the CO2 output to 0.05 kilograms per tonne. The SSAB Zero product at this moment in time is produced at our steel plant in Iowa. Only reason being, they currently have an electric arc furnace which you need to produce the material. We do ship it, I think, 4 times a year from America into Scandinavia using biodiesel ships, so we're not adding to the carbon of the material when it arrives in Scandinavia. But at this moment in time, we are currently building an electric arc furnace in Sweden, which will be the first of 3 we'll have as a company. And at this moment in time, it is actually the biggest electric arc furnace in the world. That should be operational in 2026. So end of 26, early 27, we'll also be producing SSAB Zero in Scandinavia, which obviously helps with the logistics of the material. Yeah, so just a quick recap. So we produced in Iowa using premium scrap, electric arc furnace, continual casting, gets shipped over to Scandinavia, and then we've got several downstream processes we produce at the mill in Scandinavia. We can produce hot rolled, cold rolled, galvanised, other zinc coated products, and also painted. So the transformation of SSAB, this is just a quick slide just to show where we are now and where we will be down the line. So in 2023, SSAB Zero was launched, say approximately 150,000 tonnes per year at this moment in time. That'll also be increased when we have an electric arc furnace up and running probably this time next year in Scandinavia. So 28, 29, we broke ground now on 2 new steel mills, all up in Scandinavia, to produce fossil-free steel. And in 2029, 2030, the plan is to completely decommission all of our oxygen-based blast furnaces and replace them with fossil-free steel production. This slide here just shows where SSAB are in comparison to our peers. You can see we're quite a bit ahead. I think with this current steel market, people are stepping back on their green transition due to just the way the steel market is at the moment. SSAB took the decision just to go full steam ahead, and you can imagine it's quite a cost. But it's our decision. We are passionate about sustainability, and we see this is the way forward. Puts us in a very good position, and also allows us to contribute to decarbonising the construction industry. A quick graph here just shows the savings in carbon you can make in comparison to original oxygen blast furnaces by switching to SSAB Zero. So those are the products available at the moment in SSAB Zero: hot roll plate, hot roll sheet and coil, cold roll, metal coating, colour coated. Savings are anything from 59 to 77%. So by converting to SSAB material through our partners like Firth Steels, we can really start making an impact on the decarbonisation of the construction industry. In my opinion, what we're doing here is probably one of the biggest things in the steel industry since steel was invented. It's new technology, it's been proven, and we look forward to getting this to market, and everyone in this room starts specifying our material. Is that working? That's me done. I'll pass back to Sam now to talk further about the facts and figures.
Thank you very much. So we began working with One Click back in 2024 to look at creating environmental product declarations for our full product range. So to start off with, we took our Protect system, we took our floor decks, and we took our roof decks. Working with One Click, we then got verified EPDs for each of the standard blast furnace products. So I think the charts here in extract from the One Click software is the left two columns are a standard blast furnace-based structural floor and structural roof deck. And then on the right-hand side, we then have the low carbon alternatives. So rather than going down a mass balanced approach to try and reduce our total embodied carbon, we've made it very product specific. So that we have a specific blast furnace and a specific SSAB Zero EAF-based steel. It means that the customers and the specifiers, when they're working with products, know exactly what they're getting, and it's not lost within the paperwork. It is the steel that's coming in is the steel that's going out. So I think it gives a clear background as well. On the light blue section of the chart is the steel in feed. So all of the other processes that work through remain the same. It's the raw material coming in that changes with the process. When we look at them side by side, the blue chart on the left is a standard blast furnace steel. The green columns on the right offer an EAF alternative. So you can see where the reductions are and where the reductions have been made. The route that we've taken is to rebrand the products when they are using a low carbon option. So the A1 to A3 GWP figure for SSAB Zero in plain galvanised is 733 tonnes of carbon per tonne of steel. On that basis, we've called the floor deck using low carbon R733. It gives us the ability that as we move forward, if we look at HYBRIT coming in, we may get down to an R400 or an R300 product. It gives us that ability that as different supply changes, we can continue to bring those figures down. Again, this is available across our building envelope systems. It's available on the structural products. Again, we've tried to have a comparison so we can have an identical side by side, same manufacturing processes. All we're changing is the steel that's coming in. I think that's a key point worth noting is that it is the only value we're looking to change here is the embodied carbon within the steel. So we're not looking at changing the technical specification of the product, the life expectancy, its end use. The performance specification of the steel remains identical. The only thing we're reducing is the technique to manufacture the steel in the first place. So we have a live project at the moment. We've worked with Siemens on their site up in Goole for the last 5 years. So the latest phase in the early design conversations, we were looking at the low carbon options. So very difficult to see on that chart, to be fair. The chart is split up into 4 different sections. So we supplied 8,000 metres of roof system, 8,000 metres of wall system, structural floor decking and structural roof decking. So with the building envelope product, we supplied an EAF alternative. With the floor decking, we gave the option on what savings could have been made from a low carbon perspective. So the savings across are pretty significant. So the roof system, for example, you're looking about 48 kilos per metre square on a classic system. That would drop down to 19 kilos. So you're looking at a saving of about 58%. In tonnage over an 8,000 metre project, it's about 220 tonnes of carbon that could be saved in the roof package alone. Again, we can do similar on the deck. We didn't on this project, but it is available within the range. We looked at the structural floor decking was a TR60.9 profile. In total, that contributed around 15 tonnes of carbon to the project. That could have been dropped down to 3.9 tonnes, saving 74% or 11 tonnes of carbon. If we look at the building in its entirety with the low carbon options that were available, for the roofing and cladding package, for the structural floor and the structural roof deck package, in total there's about 821 tonnes of carbon. We could have brought that down to 295, saving 500 tonnes of carbon within the project. That's everything from me. We will be around for this afternoon. So if anyone's got any questions, please give us a shout. There's a couple of my colleagues in the room as well. So any questions, let us know.